One of the things we all did as children, up to about the age of 5 or 6, is that we learned by playing. We learned by interacting. We didn't have a teacher who taught us how to walk, or a teacher that taught us how to talk. We learned how to talk because it served a purpose. We could say things. We learned how to walk so we could reach things, so we could get places. And very interactively with your environment, which includes people, you learn. And seamlessly is very important, because what happens today in many cases is that suddenly in 1st or 2nd grade, we're asked to stop learning that way and to only learn by being told, whether it's books or teachers. And so owning the laptop makes it more seamless. Low ages, another principle. If you can do 6 to 10, 6 to 12, 6 to 14, that's wonderful, but not 14 to 18. Really, the low ages are very important. Saturate an area. If this room was a school, everybody in the room has a laptop. We just don't do this 10% over here, and then another 10% in the next village, and another 10% in the next village. We do everybody here, then we do that village next, and so on. You saturate the local regions so that there is the peer-to-peer learning in this room across ages, across the differences. Connectivity speaks for itself, and free and open source also speaks for itself. Now, I happen to think that design matters. There was reference made to this being my 2nd trip to Bilbao, and it is indeed. My first one was 4 years ago, and I only came here to see the Frank Gehry building. I had a meeting in Santander, I took an extra day, came here, and you know more about this than I do, but it's remarkable to see where design and society and economy and the whole sort of well-being are so tightly coupled. So for me to talk to you about design is perhaps preaching to the choir, but I think design is important because it allows you to look at making something inexpensive in a very different way. If you've had the chance to visit India or China, you will find that inexpensive computers, inexpensive cell phones, even inexpensive cars are almost always the combination of cheap labor, cheap components, and cheap design. And the result is a cheap laptop or cheap computer. Now, the word cheap in English has a double meaning, which helps my example because the double meaning is both good in terms of it can mean inexpensive, but it also is bad because it can mean low quality or other pejorative things. The second way to make something inexpensive is to take very high numbers, very advanced production, very good design, and make it what I think will be like iPods, where you pour chemicals into a factory and outspew something that is with very little labor in between, but is using the most advanced large-scale integration possible. And it's the second one that we chose. And we chose the second one a little bit the way maybe Steve Jobs might choose it, which we're revisiting today, but for 4 years ago, it served its purpose well. And I'll just walk you through it, because since it's designed specifically for children, it has to be a games machine, it has to be an electronic book, it has to be a television set, it has to be lots of things. And this already was different. Most people who copy this idea, they don't think about it from the point of view of children. They think of children as diminutive adults, and we're going to give them a diminutive computer. No. Children are children, and children need to communicate. Children are collaborative. Children need lots of video, lots of audio, things that not necessarily go into an office computer. And so one of the things, everybody smiles when these little ears come up, is that they communicate with each other. So when you put 100 of them into a village, they automatically communicate with each other to make a network. You put 1,000 of them in, and all 1,000 make a network without the cell phone system, without anything except themselves. Now that's very important for a couple of reasons. One reason is that, let's say we're in the most remote region of an African nation. There is no cell phone, there is no internet, there is no power. But if I drop a satellite dish into that village with a generator, that costs about $300 a month. Now that's a lot of money. Well, $300 a month divided by 1,000 children is only 30 cents per month per child, which is not so much money. And the only reason you can do that arithmetic is because they all communicate with themselves. So if I connect one laptop, all 999 other laptops are connected. Now there's another reason to do it. And that is that each laptop can have, without taking up too much space, 100 books. If each laptop has a different 100 books, because they communicate. I want to read a book on your machine, my little ears talk to your laptop, and I can either bring the book into my laptop or I can read it on your laptop. Well, imagine what that means. That means that the 1,000 children in this remote village suddenly have 100,000 books. None of us went to schools that had 100,000 books. And yet, suddenly, in the remote places of the poorest part of this planet, there are 100,000 books. And one of the things we're announcing next week is that the laptop will offer with it, when it comes, 1 million free books. And that's very important, because they're free, and there are 1 million of them. So it just changes the equation very, very dramatically. I'll show you a few more things, and then I think there'll be a little time for questions and answers. When we started the project, I had passed the Media Lab on to a new director, and I was wondering what I would do with my life. And we hadn't quite said 1 laptop per child, but when we made the decision to do it, people smiled. And they said, they can't do it. And what they meant was one of two things. They either meant we as academics couldn't do it, or they meant it's impossible to do. And either way was fine with me. I loved it because I knew we could do it. And I knew we could do it as academics, and I knew it was doable. And here, this is actually the real factory today producing 100,000 laptops a month at the moment. I hope it'll go much higher. But there it is, a real factory making real laptops in 31 countries, soon to be 1 million laptops in the hands of children. So it's taking an idea and actually turning it into very large-scale production, and then those same boxes arrive in the various parts of the world. We install networks where we need to do it, and the networks are built, again, by the people, by the kids, by the teachers. You don't call Telefonica or Vodafone to come and put your network in, because they aren't there. Instead, you send a bag of parts, and the villages connect each other. This village is connecting to one that is 20 kilometers away, and it happens very organically. Now, another thing we do, again, because we're a nonprofit, is we localize. Every laptop is bilingual, but it's bilingual in languages that are so local and so, rare, if you will, that they didn't have keyboards before.